Example 1, simplify 3 square root of 50 minus 5 square root of 200. Subtraction of radicals requires the radical objects to be the same. If they aren't the same, we need to consider the possibility they can reduce so they would be the same. So if we look at each number that's underneath the radical symbol, 50 and 200, and we factor them to a prime form, 5 times 10 is the same as 50, 5 is already prime, 10 is 5 times 2. So 5 times 5 times 2 is equivalent to 50, but it's all prime numbers. Doing the same to 200, I can do, let's see, 20 times 10 is 200. 20 times 10. Helps put the correct numbers in your little factor tree here. 20 times 10. 20, you can do 2 times 10, 4 times 5. I'm going to go 4 times 5. And 10, let's go 5 times 2. 4 is not prime, so I keep going down. 2 times 2, everything else is prime. I recommend each time you do a factor tree row that you get the entire thing there, and if you hit prime numbers, you still have a composite number in there that if you break one down, you bring everything else down like that. Each row should be 20, so 200. So 20 times 10 equals 200. 4 times 5 is 20, times 5 is 100, times 2 is 200. 2 times 2 is 4, times 5 is 20, times 5 is 100, times 2 is 200. Each one of those rows equals 200, but the one that contains all prime numbers is the one we care about. So if we go back to our original problem, we have 3 times the square root of 50. We're going to change 50 into 2 times 5 times 5. For me, I like to write it in numerical order. So the smallest number grouped up, and then the next biggest number, and so on. And I've got my minus 5 times the square root of 200. Minus, and I'm going to leave a little bit of space here. So 5 times the square root of 200. But instead of 200, I'm going to write 2 times 2 times 2 times 5 times 5. So the whole point here of doing this factor tree is that if we have a pair of numbers inside the radical, a pair of numbers represents a perfect square. What's 5 times 5 equal? 25. And what's the square root of 25? 5. Okay? So if you have a pair of numbers, you're looking at a perfect square factor, the square root of that perfect square factor is just one of the pair of numbers. So a pair of 5s inside equals 1 5 outside. A pair of 2's inside is equal to 1 2 outside, because 2 times 2 is equal to 4. Square root of 4 is 2. A pair of 5's inside is equal to 1 5 outside, because 5 times 5 is 25, the square root of 25 is 5. Alright, so every time you're looking at a pair of numbers inside a radical, you're looking at a perfect square. You pull the perfect squares out. You multiply whatever you take out by what's already out there. So 3 was already out here. We took a 5 out. 5 and 3 make a total of 15. There's a 2 left in, so the square root of 2 is still in there. The second object, we took a 5 and a 2 out, multiplying by the 5 that was already out there. 5 times 2 is 10, times 5 is 50. And there's a single 2 left over also there. And once we get both radicals simplified as much as possible, they both have square roots of 2, we simplify or we add or subtract based on the sign. So 15 minus 50 makes negative 35. And then times the square root of 2, because that's what made them the same type of radical. Even if these didn't come out the same number, this is simpler than the original problem. So I do expect you to go through the factor tree process in order to pull out perfect square factors to get it as simple as possible. If you're adding and subtracting and the radicals match, you should add or subtract the coefficients. The radical will stay as is.